right, so now we're going to take a look at and focus on cybersecurity and the cloud. So this is in reference to what are the things we need to keep in mind when it comes to securing the different resources that we have available to us and the services we have available to us in the cloud. And there's no way, shape, or form here that we're going to be able to cover absolutely everything. I teach AWS classes, and we cover security in a lot of those different classes. And if you take the actual AWS security class itself, I mean, that's days and days and days and days of training when it comes to security, because there is over 125, well, there's more than that now. There's over 125 different AWS services that if you use, you got to know how to secure them. So it's about having a high level understanding of cloud security and some of the common solutions that all the cloud providers offer you. So with cloud security, the solutions vary from provider to provider, and you're going to see things like firewalls and WAFs and secure web gateways, cloud access security brokers, secrets manager, identity and access management as a common themes in all of them. Now, there's a lot more than that, but to keep us focused for the certification exam, these are the ones that we are going to be covering here. So what is a firewall in the cloud? Well, the firewall in the cloud is no different than a firewall that's in your corporate network. Firewalls are used to control the flow of traffic in and out and around your cloud environment. There you go. Control the flow of traffic using things like access control lists as an example. Permit and deny entries. So the traffic can be controlled as it comes in and out and flows around your cloud environment. So how does that compare and contrast to a web application firewall? So a web application firewall has a very specific purpose. The web application firewall is there to inspect HTTP and HTTPS traffic. So HTTP and HTTPS traffic, keep that in mind. So any scenario on the exam that's talking about cloud and it's talking about HTTP or HTTPS traffic and you want to protect it, then there's a high probability that web application firewall is going to be the answer. So the WAFs can inspect the HTTP and HTTPS traffic that is going to and from web servers that you have set up in the cloud so that you can uncover various types of attacks and various types of issues. For example, your web application firewall can identify if there's a SQL injection attack that's happening in that particular packet, or it's part of a SQL injection attack, or there's a cross-site scripting attack happening. Your web application firewall can also be used to filter who is allowed and not allowed to access those web servers through the web application firewall. So you might set up your web application firewall to deny a certain IP range that is commonly known to be utilized by hackers, crackers, and cyber criminals of the world. So as a result of that, if they try to get to those web servers and launch an attack, they are blocked by the web application firewall. Now, the secure web gateway is about protecting your corporate users from web-based threats, your corporate users from web-based threats, whereas the web application firewall is just about any regular internet user accessing your web servers, right? Well, the secure web gateway is about protecting your corporate users from web-based threats. So if the scenario is about corporate users and they're talking about the cloud, you want to protect them from web-based threats, then the secure web gateway would be the correct answer in that case, not web application firewall. So in this case here, we're dealing with a solution, a service that has the ability to apply and enforce your own corporate acceptable use policies into that cloud environment. Because this is about protecting your corporate users as they're actually accessing those web-based resources in your cloud environment. So you want to make sure that they're not susceptible to the various threats that could come along with them communicating from that corporate environment to the actual cloud services that you are offering them. So now, instead of connecting directly to the servers that are in the cloud, the users access the secure web gateway. And then the secure web gateway is responsible for connecting the users to those desired servers behind the scenes. So now that secure web gateway can be used for what? We can use it for URL filtering between the users and the servers. We can use it to to peer into the traffic flows. For example, if it's web-based traffic, let's have visibility into that web-based traffic and see what's going on with it. So that way there we can permit it or deny it. We want to identify if there's any malicious intent with these packets. So we can do malicious content inspection. We also have web-based access controls that are part of that, and various other security measures for the secure web gateway. So far you've covered 3: firewalls, web application firewalls, and secure web gateways. So paying attention to the scenario is the most critical part to answering questions correctly here in regards to these. If they're just talking about permitting or denying traffic in, around, and out of your cloud environment, then that is the firewall. If they're talking specifically about being able to inspect HTTP, HTTPS traffic to uncover various attacks like SQL injection attacks, cross-site scripting, or you want to filter out the ability for malicious IP addresses to access your servers, then that is your web application firewall. So the scenario is going to be specific about web servers. And in secure web gateway, it could be any servers, any resources behind that secure web gateway. So in the scenarios, your corporate users, you're trying to protect them as they are accessing those cloud resources that you're offering for them. So you can do, like I said, URL filtering, web visibility, content inspection, and so on and so forth with that. So that's how you're going to keep those separate for the exam, unless you wanted to spend some time researching them even deeper and set them up in AWS as an example to learn more about them. But that's beyond what you need for this certification exam. You have the 35,000-foot view of what these do for you. Now, Cloud Access Security Broker. What is this? So this can be either an on-premise solution you have or a cloud-based solution. So it could be on-prem or it could be cloud-based. And what it is it's a security policy enforcement point. A security policy enforcement point. And you place this security policy enforcement point between the consumer of the cloud resources and the provider of the cloud resources. And the whole point of the Cloud Access Security Broker is to ensure that as the cloud users are accessing the cloud services, the enterprise security policies are being adhered to as the cloud-based resources are being accessed. So just because you move to the cloud doesn't mean you can totally forget about all the policies, regulations, procedures, compliance requirements, and everything like that goes along with your enterprise environment. You still have to consider all of that in the cloud, and the Cloud Access Security Broker can help you out with that. So the Cloud Access Security Broker can consolidate multiple types of security policies for you and enforce them on. So security policies relating to authentication, single sign-on, authorization, credentials, device profiling, encryption, tokenization, logging, alerting, malware detection and prevention, right? Whatever type of policies you have in your environment, we can make sure that those are in the cloud. So if for some reason you're accessing a cloud resource and those policies are not in place on that cloud resource, then we want to deny access to that. So we permit access when policies match. We deny access when policies don't match. Cloud Access Security Broker. So if we want to block, for example, access to unsanctioned SaaS applications, meaning SaaS applications that we do not approve of because they don't meet our policy requirements, that's why they're unsanctioned, then a Cloud Access Security Broker can help us out with that. So the Cloud Access Security Broker could be something you manage yourself, or it could actually be a third-party entity that you hire and they do it for you. Secrets Manager. I like secrets managers. It is a cloud service that provides a secure, encrypted location to store as well as retrieve secrets. All right, so what's a secret? A secret can be, for example, a password, or it can be a set of access keys. Now, why would I want to store passwords and access keys in a secrets manager, right? I do this so that way there I don't have to embed passwords or access keys, these secrets, into the actual applications that we are developing and using. Instead, I can develop the application to make an API call to the secrets manager to retrieve the encrypted keys, the encrypted password, so that way there it can use it. So with Secrets Manager as an example, let's say we have a front-end web server and a back-end database. The database requires authentication to it. So if the information that was put into a web form needs to be entered into a database, well, how does the web form authenticate with the database? Well, one way we could do it is put the username and password into the web app. Not a good idea, because if the web app is compromised, then the username and password will be read right in the web app's code. We don't want that. So it's better to instead code the web app to call the secrets manager and grab the encrypted credentials from secrets manager and then use those credentials. That way they're not embedded in the actual application or the actual service. So that's an idea behind secrets manager. Identity and access management. What is this all about? This refers to our ability to create users, create groups, create roles, and apply policies and permissions for authentication and authorization purposes. So this is how in the cloud we would control users and their ability to interact with all the different resources. However, if you already have an existing LDAP database, you have an existing SAML option or OpenID Connect option that you can go ahead and use, well, then those are also options. You don't have to create users, groups in your cloud environment. You can actually piggyback on top of some already existing database. So through the use of something like Active Directory Federation services, instead of populating in AWS as an example, usernames and passwords and all that stuff, I could jump on the already existing Active Directory database and use that and control authentication through that as an example. Now, when it comes to storage in the cloud is very convenient. I love cloud storage. It's convenient, it's low cost, but also very dangerous if you are not taking the precautions needed to protect that data that you are storing in the cloud. So first and foremost, access to the data must be strictly controlled so that only authorized users are able to access the data and use it. That was a big challenge for a lot of people when they first started using Amazon S3 services. They did not fully comprehend what the access controls meant, and they failed to research them and learn about them because maybe they were in a time crunch to implement them. So they were taking certain documents that maybe were confidential for the entire organization, throwing them in Amazon S3, making them public, thinking that meant anybody who has access to that Amazon S3 account, which was everybody in the organization. No, public meant the entire world. So therefore, all of a sudden, we had data breaches simply because cyber criminals were starting to write scripts that could look for any publicly available Amazon S3 location and then download all the data from it. So there's tons and tons of data breaches, all because the access controls were not set properly in Amazon S3. So it's important. You cannot start using a cloud solution until you understand and fully are able to protect access to that data. And then also, any data you put in the cloud must be encrypted. Now, some cloud providers and some cloud services force encryption nowadays, but in the past they didn't, meaning that you might have some older data sitting there right now that you didn't encrypt because encryption was not forced upon that data originally. And until you replace that data, it will not be encrypted unless you go in there and encrypt it right now. So it is imperative going forward that you consider making sure that everything from the past that's not encrypted gets encrypted. Everything in the future is always encrypted at rest and encrypted in transit from system to system when you are in the cloud. Now, availability should also be a concern. Now, with AWS, I am not worried about them losing my data. That's right, I'm not. Why? Because they have a lot of features built into their services automatically that ensure availability. So if they have an issue, they have a problem, they have an outage, they have a loss of a hard drive with my data on it, they don't actually lose my data. Because essentially, behind the scenes, when I upload something or I'm using one of their services and I put data in there, whether it's an Amazon EC2 EBS volume, whether it's an RDS, or whether it's in something like Amazon S3 or EFS or anything like that, they make copies of it on other systems that would not be affected by the same type of outage. So if a certain system had an outage, maybe even the building caught on fire, my data is actually in another building somewhere that should not actually catch on fire as well. So that's really nice, okay? So they already have controls in place to protect my stuff from their problems. But here's the thing, if I have an issue, that's not their problem, that's my problem. That's on me. And they will not help me out with that. So when I say I have a problem, what does that mean? Well, it means that somebody could have accidentally clicked the wrong button and deleted the data. Okay, well, Amazon is not going to be able to recover that. Because once somebody deleted that data, it deletes the main copy plus the backup copy as well off of Amazon's site. See how that works? So now all of a sudden, okay, that's a me problem. A cyber criminal goes in there and starts erasing all my data. That's a me problem, not an Amazon problem. Cyber criminal goes in there and starts encrypting everything with their own sets of encryption keys that I don't potentially have access to when it's all said and done. Again, my problem, not their problem. So I still need to consider replication and backups for my own possible availability issues or disaster types of issues. And so that way there, if something does go wrong, something bad happens by accident or on purpose, I'm going to be able to recover that data because I've replicated or I have a backup of it. Compliance with data sovereignty rules must be obeyed. For example, in AWS, I have access to the Europe data centers. I have access to the North American data centers. I have access to the data centers in Brazil. I have access to the data centers in Canada. Well, that's part of North America. I have access to Australia. Right, I have access to all of those different data centers. Now, there's some of them I don't have access to because of legal rights and requirements and different things like that. But just because I have access to those data centers doesn't mean I can do whatever I want with them. For example, when it comes to those data sovereignty rules, I need to make sure that the data I generate and store is being stored the right way in these particular data centers. Or else I may not be in compliance with data sovereignty rules. How many of you have heard about GPDR? We'll talk about it later. It'll be tomorrow's session, GPDR, just so you can answer questions on it on the exam. But in a nutshell, it's about data sovereignty rules for Europe. And one of the things is if the data is actually generated in Europe, it has to stay in Europe. So as a result of that, if I have servers generating data in Europe, could I store them in a North American AWS location? No, I can't. Because that would all of a sudden break the data sovereignty rules. So the thing about cloud storage is you have to be careful now because it's really easy to store data wherever you want. Whereas if it's not the cloud, then you'd have to build an entire data center, right, in that area or put servers up in that area. There's a lot of physicality involved. In the cloud, there's not. Click some buttons, do this, do that. Next thing you know, your data's somewhere else completely. So you got to make sure you're following those rules or you could be in a breach of compliance. And the same thing's true, like if you're using a SIEM that we talked about in the cloud, because if you are collecting logs from all of these different areas throughout the world in the cloud, maybe you have a centralized location in Virginia where your SIEM is running and you're collecting information from logs in North America, Australia, Europe, and you're storing them now in Virginia. And then you're monitoring them. Well, that could result in non-compliance. You're going to have to double check on that before you do something like that. Cloud networking. Cloud networking is very, very, very similar to your on-prem data centers. I can create virtual networks just like the physical networks I have in an on-prem data center. And these virtual networks are going to have to be secured at a minimum, just like your on-prem networks. So, do we create different subnets? Yes. Do we create different security zones? Absolutely. Do we do things for public resources differently from private resources? Absolutely. So, making sure that we set up our environments in a way where we can control the traffic that's flowing from public subnets to private subnets is being done in a safe and secure way by routing appropriately, filtering appropriately with firewalls and network access control lists, setting up security groups, so that way there we can control traffic at even a more fine, granular level. And then setting up endpoints, so that way there traffic that would normally go from a server in the cloud environment out to the internet and then back to another service in the same cloud environment doesn't flow that way anymore. It flows from the resource in the cloud environment through the back end to that resource in the cloud environment. You might say, well, why would that even happen in the first place? Because of the way it's designed. There are some resources that are designed to be accessed from the internet. So if I have an internal resource in my cloud environment and I'm accessing a resource that's typically accessed from the internet, then by default, it's going to go the internet route. But if I set up an endpoint, a VPC endpoint as an example, then I can change the flow and stay inside the cloud environment instead of going to the internet and back. Setting up VLANs, isolation, segmentation, so that way there we can maybe separate the production environment from a non-production environment. So even in the cloud, setting up production networks, non-production networks, so testing networks, or networks for internal users versus public users and different things like that. Very, very important. Isolation, segmentation, segregation, everything you possibly can do, you want to do just like you do in a regular physical network in your data center. And then compute security. Just like on-prem resources, we're going to have to harden our cloud resources. And so before we talk about compute security as an example, depending on the resource you're using in the cloud, and whether it's an IaaS, PaaS, or SaaS resource, is going to ultimately determine the level of hardening that's going to be required by you. So, for example, with a compute resource in the cloud, such as a virtual machine, in AWS, it's called EC2 instances. So what would I need to make sure? I need to make sure that the operating system and applications and services are all patched and up to date regularly, and that I have only the services we absolutely need running are actually running. I need to constantly log and monitor and audit the resources to make sure that nothing abnormal or malicious is happening to my virtual machine. I want to consider installing a host-based firewall on the server to control which applications, services, and ports are permitted and denied. I want to consider a host intrusion prevention system, so that way there, if the service starts to behave in an abnormal way, we can be notified and any malicious activity can be stopped. I might want to think of an EDR solution, endpoint detection and response solution. Install some antivirus, install some anti-malware to help protect us from those threats as well. So that's an example of an EC2 instance. But if I was using some other resource, right, I'd have to educate myself on how do I secure this resource. RDS, I would do some things a little bit differently, because in RDS in AWS, Relational Database Service, I don't have to patch the operating system. That's taken care of by AWS. Do I still have to do things like logging and auditing? Absolutely. Can I put a host-based firewall on it or intrusion prevention system? No. Or anti-malware? No. Right? So those things would be eliminated, but some of the other things still exist. Right? What are my options for Amazon S3? What are my options for EFS and this and that and the whole 9 yards? So, right, when it comes to security in the cloud, you have to take the time to learn on a resource by resource, service by service basis exactly what is you are responsible for securing those resources from the big bad internet.